So far, you have a beam attached to a motor and a simple program that generates a tone, a high-pitched tone if it's somewhere between 100 and 200 degrees, and if it's anywhere else, it generates a low-pitched tone. So let's modify this to make an actual coin detector. Let's say you have a hard stop here, some piece of plastic or a beam that doesn't move, so that you can lie a coin, let's say this is coin A, on the surface, and as you rotate the motor, the beam will eventually hit coin A, and it will have rotated X degrees. Remember, we have our rotation sensor inside the motor. We'll say it's reading X at all times, where X is the position of this beam. And let's say, for example, coin A is at 91 degrees. Now, if we're thinking like a robot, we don't actually see the coin. The only thing we see is this number. So for the robot, 91 degrees is somehow representing coin A. And if we put in a smaller coin, this beam will rotate further down and it might register 98. So the robot will know, oh, we're in 98, this is not the correct coin. So the problem here is to basically squeeze your range to be some tiny slice here that represents coin A, and it won't be a one reading such as 91 degrees because there'll be a tiny bit of variance here. It could be 91, 92, or 93 degrees. Perhaps, and this all depends on your system. You have to figure out what this range is. So if it's inside this little slice, we'll call range A, and if it's anywhere else, it's our reject region. Sorry, this will be our accept region, think of it, and the rest is our reject region. And to make this work, you need to modify your program in 3 ways. We don't want to generate a tone in real time as before. We want to actually wait for the user to put in their coin and rotate the motor, and then the user will hit the orange enter button. So that means you're going to need to introduce a wait block inside your infinite loop. So it will wait for the user before it goes and plays a tone. And after the user presses the orange button, you will either generate an accept or reject sound file. So don't generate a tone, it needs to be meaningful, such as yes or no. And the third step, and the main engineering problem here, is to figure out what the range is for your system. Remember, this is 0, so you're going to have to pull your sensor and experiment a few times to figure out what is your range for, say, a 5-cent coin, and change your range values inside your existing range block. And if you do these 3 things correctly, you should have the following working coin detector.